Today we're going to be talking about the t-test and how to do them in SPSS. So we're going to talk about three different types of t-test. With the t-test, something to think about it's comparing only two things. So that's an easy way to remember the t-test. It just compares two things. Yeah, I think of it as the t standing for two, even though it doesn't. Only comparing two things. So the three different types. The first type is called a one samples t-test, and with the one sample t-test, you're comparing your one sample to a known value. And give you an example of that in a second. The second type is an independent samples t-test. You're comparing two groups of different people in each group, so they're independent samples of each other. And then the final one is a repeated measures t-test. SPSS will call it a paired t-test, but it's where you've got the same people measured twice, so they're repeated over time. So I'll go into this data here. The first couple that I'm going to go over are with this clinical data. This is a group of people who are being treated for anxiety, and primary diagnosis is anxiety disorders. So what we want to look at I want to look at how their depression is. So I just picked a random variable, and the first test we're going to look at is their depression. So I'm going to compare whether they have significant amount of depression. So I want to compare this one sample of patients to a cutoff score for depression. So I'm going to use the one sample t-test. And this is the measure of depression I've got here, the Beck Depression Inventory. It's a raw score. And I'm going to compare it to a cutoff of 17. And so the Beck Depression Inventory, I could compare it to 0. And if I compare it to 0, I'm basically saying, is there any depression in this group? And I'm quite likely to get an answer of yes. But by comparing it to 17, on the Beck Depression Inventory, 17 is the lowest score for mild depression. So I want to see, is there a significant amount of depression in my group above 17? So that's why I chose that value of 17. If I could choose any number. I could choose 0 and compare it to any amount of depression, but I want to see, is there a mild amount of depression or more? So I'll click OK, and we'll get our output here. And so what I've got 376 people. This is the average amount of depression, so a score of 18 on the Beck Depression Inventory, and then I've got my standard deviation, standard error of the mean, and then here's my one sample t-test. So this is the t-value, 2.529, 375 degrees of freedom, which it's n-1, so you see my sample size is 376, and then my p-value is 0.012. So the significance is our probability that the null hypothesis is correct. So I've got a very small probability that the null hypothesis is correct, so I'm going to reject that null hypothesis. So that's at 0.012. And then below we've got our Cohen's d effect size down here, so we can see what this number is, and so a pretty so 0.130, and then we have a confidence interval around that effect size. So this is our one sample t-test. This is probably the one that's used the least, because usually you're comparing it to another sample, or you're comparing two time points. You're not often comparing it to a set score. So the second one we're going to cover is a independent samples t-test. So now we've got two groups, and we want to see, are these groups different from each other? So in this example, again, I'm going to use this Beck Depression Inventory as my dependent variable. And what I'm going to check is whether people with anxiety disorders who have comorbid depression are different from those who do not have comorbid depression. So I've got this variable here on comorbid depression, and it's a 0 if they don't have comorbid depression, a 1 if they do have comorbid depression, So I define the groups that way. And so we're going to see, is there a difference in the amount of depression on this measure for people who do or do not have depression? We probably already know the answer to this, but we're going to do this anyways as this test. All right, so what we've got here on the top, we get our descriptive statistics as usual. We've got 204 people without depression, 171 with depression. That makes sense for an anxiety sample. We usually have quite a bit of comorbid depression. We see the means, 12 for people without depression, 25 for people with depression, and you saw that cutoff I talked about a minute ago of 17. So 25 is higher than 17, and so we makes sense that we have higher amounts of depression. It's a pretty big difference we were seeing already, so I think when we look at the t-test, we're going to see a significant difference. When we come down to the t-test, the first thing we're going to look at is this Levine's test for equality of variances. So there's an assumption of homogeneity of variances in independent samples t-test. So we want our variances to be equal. Quite often, when we don't have equal sample sizes in the group, we won't have variances being equal. So this Levine's test tests for this assumption. And the way I think of this Levine's test, it's very similar to every other test that we have, where we're looking at a null hypothesis that says nothing is happening. So in this case, the variances are equal. And when we reject this null hypothesis, we're saying that the variances are not equal. So in this case, that significance value, that p-value, is less than 0.05. So we're going to reject the null hypothesis that the variances are equal to each other. So this is one of those strange situations. Usually we want our p-value to be significant. That means we found something. In this situation, for Levine's test, we don't want it to be significant. We don't want to find the variances to be unequal. So what do we do with this? So do we just quit and say, I'm sorry, we can't do a t-test? We could do a non-parametric test. However, we can also, SPSS gives us this value down here that says equal variance is not assumed. The second row tells us, gives us a correction factor. And so we'll just use this second row here instead of this first row. So let me just kind of clarify that. When Levine's test is not significant, you can use this first row. When Levine's test is significant, you use the second row. So when we look at the second row, our t statistic is negative 13, and it's significant. So it's less than 0.05. So it's a significant t score. We reject the null hypothesis. The two groups are different from each other, which is pretty obvious here, 25 compared to 12 in the mean. So even when we do this correction, we still have a significant difference between the groups. And then if we look down here at Cohen's d, we've got a negative 1.4. That's a large effect. There's a large difference between these groups. So that's also kind of reiterating this difference between the groups. So here's our Cohen's d, negative 1.1454. All right, so the last test, type of t-test, I'm just going to switch data sets here because I need something with repeated measures in it. So in this data set, we're looking at kids from birth until age 15. We're looking at a lot of different scores. We're going to look at internalizing disorders. So this is internalizing disorders or depression, anxiety. And with our kids, we've got the internalizing scale as determined by the mothers at 24 months and 36 months. So this is what I'm going to use for our next t-test, the repeated measures t-test. So I'm going to go to Analyze, and again, Compare Means, and I'm going to go to Paired Samples t-test. So again, SPSS calls it Paired Samples t-test. I'm doing it at Repeated Measures t-test. It's got a few different names to it, unfortunately, but it's a Repeated Measures t-test. And what I'll do is I grabbed my two internalizing scores. I did this before this video, and so this is internalizing at 24 months and then internalizing at 36 months. This pair goes here, and this is what I'm going to analyze. So One of the limitations of a t-test is you can only have 2 time points or 2 groups. So we have a lot of limitations when we do t-scores or t-test, because I've got 24 months, 36 months, 54 months, grade 1, grade 2, grade 3. I've got a lot of scores, but I can only compare 2 with the t-test. So we'll get into some other ways of analyzing repeated measures data where we can measure more time points, but this is just looking at whether these 2 time points are different. Okay, so I'll hit OK. We've got on the top again, we've got our descriptive statistics like we've had throughout. So we've got, these are t-scores, so there's an average of 50 on these t-scores. So 50.219 time 1, 51 at time 2. We've got 1,140 people. That's a lot of people in a sample. It can affect our t-score, making it more likely to be significant. So let me just kind of reiterate that. When we have a lot of people, we can really find effects very easily. So we have to be careful with large samples that we also look at the effect size. So I'll go over that in a second in a little bit more detail. So we also have a correlation between the 2 time points, which is useful because these are the same people measured twice. We want to see how their time 1 score is related to time 2. So it's correlated 0.65, which is pretty high correlation. We'd expect a child's internalizing disorder at 24 months to be pretty similar to their internalizing at 36 months. And then here's our paired samples t-test. This mean is the difference between those 2 time points. And then if we go further down the row, we've got a t of minus 3.799, which is significant. So this p-value is less than 0.05. So the probability that the null hypothesis is true is really, really small, so we reject that null hypothesis. So again, I mentioned with large samples, it affects this significance. So that degrees of freedom, or the number of people, is calculated in this final number here. So sometimes with these really large studies, we find it significant, but that's not a very big effect because this large sample allows us to find small effects. And then here we've got our Cohen's D score, and we can actually see it's a smaller effect. So we've got a negative 0.113, so we can actually see the effect size. So I think it's important to report this effect size as well.